Welcome to the Tech Room, your weekly breakdown of semiconductors, AI, and gaming. I'm Jess.
And I'm Mark. This is the podcast brought to you by SBN Media Studio.
Today on the show, we have a packed agenda. In semiconductors, the foundry landscape is facing a massive shakeup, with Intel's 18A node showing real momentum, while TSMC's advanced packaging finally breaks through a major bottleneck. In AI, those unblocked chips are officially powering a massive rollout of real-world persistent agents from Google, OpenAI, and Anthropic.
The thread connecting it all this week: how the physical unblocking of silicon supply chains is directly triggering the deployment of consumer and enterprise AI agents at a global scale. Let's dive in.
So if you're tracking tech stocks right now, or even if you're just trying to wrap your head around all those sudden AI features popping up on your phone, you really have to understand the hardware.
Oh, 100%.
Right. Because it's the only way to see where the software is actually going. I mean, think of it like, imagine you're building this massive, state-of-the-art, multi-billion-dollar highway system.
Okay, tracking with you.
It's an absolute marvel of engineering. But then, right as you're about to open it to the public, you realize all the on-ramps are just like these single-lane dirt roads.
Yeah, which is just setting yourself up for, like, the most expensive traffic jam in human history.
Exactly. And honestly, for the last couple of years, the AI revolution has looked exactly like that highway.
Yeah, it really has.
We've had these incredible destination models, right? These massive software breakthroughs. But the physical infrastructure, the silicon manufacturing, it was all totally gridlocked.
Completely gridlocked, yeah.
So our mission for this deep dive is to trace the exact pipeline of how that physical dam is officially broken.
Right. And how all that water is now just rushing downstream directly into the software you use every single day.
Exactly. So we really have to start at the foundation of the whole ecosystem, which is the foundries, the companies actually manufacturing the chips.
Because the capacity strain right now is just unprecedented. I mean, it's leading to some truly shocking shifts in alliances.
It really is. I mean, for years, TSMC, Taiwan Semiconductor Manufacturing Company, they've been the undisputed king of advanced chip making.
Oh, totally. They've had a virtual monopoly on the bleeding edge, but the sheer volume of demand for AI silicon right now is straining even their massive capabilities.
Right, and that strain is opening a window for a resurrection that, honestly, a lot of people thought was mathematically impossible.
Intel.
Yeah. Yeah, according to CNBC, they recently had an interview with Intel's CEO, Lip-Bu Tan, where he confirmed that Intel's new 18A manufacturing process is seeing yield improvements of like 7 to 8% month over month.
Wow, that's significant.
Right. And to give that some context for you guys listening, a yield improvement basically means that out of every silicon wafer they bake, a significantly higher percentage of the individual chips are actually functional rather than, defective.
Right. They aren't just throwing half the wafer in the trash.
Exactly. And on top of that, according to the Wall Street Journal, who broke this story, Intel Foundry has signed 2 new external customers since the first quarter.
Yeah, and one of them is huge.
Huge. A preliminary deal with Apple.
Wait, really?
Yeah. And Panther Lake chips built on this 18A node are ramping up in Q3. So we are looking at Intel's most material foundry momentum since, like, the 22-nanometer era.
Okay, I need to step in here and play devil's advocate for a second.
Go for it.
Because we cannot ignore the historical context here. Like, we all remember Intel's infamous 10-nanometer disaster.
Oh, yeah. Painfully.
Those manufacturing delays dragged on from 2016 all the way to 2019. I mean, they burned a staggering amount of industry credibility.
That's completely true.
So the question we have to ask is Apple booking with Intel because this new 18A node is genuinely a technological triumph? Or is this just Apple buying, like, a standby ticket on a budget airline because TSMC First Class is completely overbooked?
Okay, it's a fair challenge. It really is.
I mean, the data from Silicon Analysts points heavily toward the overbooking theory.
Right, let's hear the numbers.
Okay, so TSMC's 2-nanometer capacity, specifically across their cutting-edge fab 20, 22, and 21P3 facilities, it is completely sold out through 2027.
Sold out through 2027 is a terrifying phrase for an operations executive.
It's a nightmare. And when we talk about a 2-nanometer node, we're talking about the microscopic scale of the transistors. Smaller nodes mean you can pack way more computing power into the exact same physical space.
Right, it's all about density.
Exactly. And Apple already holds over 50% of that 2-nanometer allocation, but it's still not enough for their massive iPhone and Mac volume requirements.
Yeah, the volume they need is just astronomical.
And even their slightly older 3-nanometer lines are severely constrained. We're talking lead times stretching from 52 to 78 weeks.
Wow.
So when you are operating at Apple's scale, you just simply cannot afford to have a single point of failure in your supply chain with lead times that long. I mean, they practically have to diversify.
Okay, I don't disagree on the capacity constraints at all, but there is a massive strategic and geopolitical business reality we have to factor in here too.
The GPS Act.
Yes, the Cheap PPS Act. It injected billions of dollars into Intel's U.S.-based fabs. So this preliminary Apple deal, I mean, it feels like a play for geopolitical supply chain resilience just as much as it is about raw performance.
Yeah, having a domestic backup plan that isn't sitting on a geopolitically tense island is just good business.
Exactly. But to truly understand why these foundries are so bottlenecked in the first place, we have to look at the tools they use to physically print these circuits.
The lithography.
Right. The immense difficulty of adopting next-generation manufacturing equipment is just staggering.
Speaking of the machines powering all of this, let's talk about what's happening on the lithography side. Reuters is reporting on a fascinating announcement from the IMIC Future Summit.
Oh, the ASML news.
Yeah. ASML's CEO, Christophe Fouquet, stated that the first commercial chips produced on their new High-NA EUV systems will hit the market in mere months.
Which is crazy fast.
It is.
Yeah.
And ASML is sitting on a $40 billion backlog for these machines.
Yeah.
Intel and SK Hynix are stepping up as the early adopters. But TSMC, on the other hand, is intentionally delaying their adoption of High-NA.
Okay, let's pause right there, because for those of us who don't have PhDs in optical physics, can you break down the actual difference between this new High-NA EUV and the standard EUV that TSMC is currently using?
Yeah, absolutely.
Like, what is the actual mechanism changing here?
So the secret sauce is the NA, which stands for numerical aperture. It essentially measures the light gathering capability of the lens system.
Okay, light gathering, got it.
So think of standard EUV like trying to paint a microscopic masterpiece by shining a flashlight through a stencil.
Oh.
You can get fine details, but the light scatters slightly. So to get those incredibly tight 2-nanometer lines, TSMC has to trace over the same area multiple times.
What's called multi-patterning, right?
Exactly, multi-patterning. And it is incredibly slow and expensive. High-NA changes the lens, it widens the angle so the system can capture and focus light with wildly sharper precision.
Oh, so it's essentially upgrading from a magnifying glass to like the James Webb Space Telescope for etching silicon.
That is a perfect analogy, yeah. You can print those microscopic patterns in a single pass.
Wow, so Intel is basically buying the Space Telescope to try and leapfrog the competition, while TSMC is making a calculated risk.
Very calculated.
Right, because TSMC has decided that the jaw-dropping $400 million price tag for a single High-NA machine just isn't worth it yet.
Yeah, they're betting they can squeeze more efficiency out of their older equipment.
But here's the thing. The lithography is just how you print the chip.
Yeah.
Once you print, you actually have to package it.
Right.
And here's where we hit the real structural shift. Because while the foundries battle over lithography, the biggest choke point from last year at advanced packaging has quietly been solved.
You're talking about CoWoS packaging.
Yes, CoWoS.
Uh-huh.
According to Bloomberg's reporting from TSMC's 2026 Technology Symposium, TSMC's CoWoS advanced packaging yields have officially hit 98%.
That's incredible.
And their capacity will double in 2026.
Okay, so CoWoS stands for chip on wafer on substrate. And to understand why a 98% yield is a miracle, you have to look at the physical mechanics of it.
Right, it's not simple.
Modern AI chips aren't just one piece of silicon. They require a logic processor and stacks of high bandwidth memory to sit right next to each other.
And they have to communicate instantly.
Exactly.
Yeah.
CoWoS places these different components side by side on a microscopic silicon bridge called an interposer.
And the margin for error there is essentially zero. Right?
Literally zero. Because silicon warps when you apply heat. If you misalign a microscopic wire by even a fraction of a millimeter while fusing these components together,
You ruin it.
you don't just get a slightly slower processor, you have completely ruined a $40,000 AI chip.
Ouch.
Yeah. And for the last 2 years, this was the single biggest bottleneck in the AI revolution. It didn't matter how fast you could print a GPU if you couldn't properly package it with the memory it needed to function.
So hitting a 98% yield means they have finally mastered the thermodynamics.
Yes, they are no longer throwing away massive volumes of finished silicon.
And this officially removes the bottleneck for the absolute massive AI chips coming down the pipeline, like NVIDIA's Vera Rubin architecture and AMD's Instinct MI400.
Which is huge.
It is. The packaging is unblocked, the compute is accelerating, but And there's always a but clearing. That dam just sends the floodwaters crashing into the next weakest link in the supply chain.
Right, because the compute is so fast now, the processors are just starving for data. We have a brand new crisis, Jess, and it's memory.
Yeah, the data volume required to feed these unblocked GPUs is just tearing through the global supply of DRAM.
It's insane.
I was looking at the numbers from a Tom's Hardware report,
Hmm.
and it is physically difficult to comprehend. OpenAI's Stargate project alone is projected to consume 40% of the global DRAM output.
Wait, global, like 40% of all DRAM?
Yes. Let that sink in.
Yeah.
Nearly half of the entire planet's production of this specific type of memory is going to a single project.
That is just unprecedented demand. And, when you have that kind of demand, the memory suppliers realize very quickly exactly how much leverage they hold over the entire tech industry.
Oh, and they are certainly flexing that leverage. We're seeing suppliers like Kioxia slash their capital expenditures down to a mere 5%.
Which is crazy low.
Right, because the historical average for building new factories and maintaining equipment is usually well over 20%. So they are enforcing severe supply discipline.
Yeah, they are intentionally keeping production tight.
Refusing to build new lines and just letting the sheer panic of the hyperscalers drive the prices up. Analysts project this oligopoly strategy will drive NAND average selling prices up by 250% this year alone.
250%. I mean, it's brilliant, ruthless economics. By keeping supply artificially tight, they basically force the Googles, Microsofts, and Metas of the world into highly profitable long-term agreements.
Absolutely.
They are locking in their margins for the rest of the decade because the hyperscalers literally have no choice but to pay up.
Which brings us to the ultimate so what for you, the listener.
Yeah.
Because we spent time deep in the trenches of silicon manufacturing today. But the reason this matters is what that cheap, unblocked hardware enables in your daily life.
Now, all those chips have to run something, and this week in AI, there's a lot to unpack.
With TSMC's packaging yielding at 98%, AI companies finally have the raw, cost-effective compute power they need to run massive models all day, every day.
Yeah, we are officially exiting the hype phase of generative AI. Where you ask a chatbot to write a poem or whatever, and we're entering the deployment phase. We are seeing persistent, real-world AI agents escaping the lab and integrating directly into our finances and our workplaces.
Definitely. The Verge had a really great breakdown of Google I/O 2026, where they unveiled Gemini 3.5 Flash. Now, the big headline here isn't necessarily the smarts of the model, it is the economics.
Right, it's always the economics.
Google dropped the input token pricing by a massive 40%. They brought it down to basically 7.5 cents per million tokens.
Which is wild. And for anyone wondering what a token is, think of a token as roughly a single syllable of a word.
Okay.
So when Google drops the input token pricing, they're basically slashing the cost of the AI's reading budget.
Oh, I like that, reading budget. And that drastically cheaper reading budget is the exact mechanism that enables their next announcement. Gemini Spark.
Spark, yeah.
Spark is a persistent personal agent. It is not a chat window you occasionally type into. It has persistent read access to your Gmail, your calendar, your Google Drive, and your maps.
It just runs in the background continuously.
Exactly.
And if we connect this back to the silicon, that 40% cost reduction is literally the only reason an agent like Spark can even exist.
Right.
Because if the computational cost of inference, which is, the process of the AI actually running its calculations, if that was still as high as it was in 2024, having an AI constantly reading your inbox and cross-referencing your calendar would bankrupt Google in a week.
Oh, in days.
Right. So cheap, abundant compute from those unblocked foundries is what makes a persistent background agent economically viable.
They also launched Gemini Omni, which supports a 1 million token video context window, positioning it directly against GPT 5.5.
Wow.
But OpenAI is moving just as aggressively, taking their newfound compute capacity in a highly specific, deeply personal direction.
Yeah, the personal finance stuff.
According to an official OpenAI blog post, ChatGPT just launched a personal finance preview for their pro users in the US. They've partnered with Plaid to connect ChatGPT to over 12,000 financial institutions to offer what they call a cash flow coach.
Okay, so Plaid basically acts as an API middleman, meaning OpenAI doesn't store your bank passwords directly, but they are absolutely ingesting the structured data flowing through.
Right, all the transaction data.
It surfaces your portfolio, your spending habits, your subscription dashboards. It is read-only at launch, but their documentation explicitly states that automated trading and fund transfers are the next phase.
Which is a massive leap in utility.
Jess, it's a massive leap in privacy invasion is what it is.
Yeah.
Look at your own banking app right now. We are jumping from asking a chatbot to write a polite email to our boss to handing an LLM the keys to 12,000 banking institutions.
It is a jump.
Right. How comfortable should the average listener be with an AI scraping their daily coffee purchases, their mortgage payments, and their retirement portfolios just to tell them to budget better? I mean, that is the exact privacy versus convenience cliff we are standing on.
It's a cliff, for sure.
Yeah.
But honestly, historical consumer behavior tells us people will jump if the parachute is convenient enough.
That is sadly true.
Right. The market is betting that having a hyper-intelligent, always-on financial advisor for $20 a month will absolutely outweigh the privacy hesitations for millions of people.
Yeah.
And it isn't just everyday consumers making this leap. Massive multinational corporations are standardizing on these models.
Oh, yeah. The Financial Times broke the story that KPMG and Anthropic just signed a global alliance.
This is huge.
It's massive. KPMG is deploying the Claude AI model to 276,000 employees globally for tax and audit workflows.
Wow.
That means 3 of the top Big 4 accounting firms in the world are now exclusively standardized on Claude.
276,000 seats. I mean, the sheer scale of that deployment is staggering.
Yeah, it really is.
And tax and audit workflows are incredibly dense. They are highly regulated, detail-oriented, and one mistake can trigger millions in liabilities. The fact that KPMG trusts Claude to assist with this at that scale is a testament to how reliable the underlying technology has become.
Well, it works because of the massive context windows these models now have. I mean, audit work is essentially taking mountains of unstructured financial data receipts, ledgers, emails, understanding the insanely complex rules of the corporate tax code, and structuring that data into compliance reports.
Right.
It's a perfect use case for a highly capable LLM. But again, a model that can process a 500-page tax document in seconds is only possible because the CoWoS packaging bottlenecks we discussed earlier have been cleared, giving Anthropic the server racks they need to actually run it.
Okay, if you zoom out from everything we just covered, there's a clear thread.
Yeah.
The unifying theme for you, the listener, is the transition from building the engine to actually driving the car.
Yeah.
In 2024 and 2025, the AI revolution was constrained by physical hardware. It was held back by the thermal dynamics of CoWoS packaging and the gridlock of foundry capacity.
But now,
TSMC has mastered the packaging with 98% yields. Intel's 18A node is finally providing alternative compute capacity. The hardware dam has officially broken.
and that unlock is exactly why we are suddenly seeing companies like Google, OpenAI, and KPMG deploying these persistent agents. The chips are finally available, and they're finally cheap enough to run inference at a global scale.
Oh, exactly.
But, solving one constraint in a complex system usually just shifts the stress test further down the line. We unblock the compute, which means the processors are moving faster, which means they're chewing through memory faster. So now we are playing a multi-billion-dollar game of whack-a-mole with the memory market, where Kioxia and others are restricting supply and driving prices to the moon.
It never ends.
Yeah.
So looking into next week, Mark, what is the single thread you are keeping your eye on?
Well, I am watching the memory market very closely. With suppliers intentionally squeezing the availability of DRAM and NAND, I want to see if the hyperscalers like Meta or Microsoft try to bypass these traditional suppliers entirely.
Oh, interesting.
Yeah, do they start heavily investing in custom memory architectures or totally new storage technologies to dodge these 250% price hikes? They have the capital to fund their own solutions if the traditional market becomes too hostile. What about you, Jess?
Well, I'll be keeping a close eye on the enterprise AI wars. With KPMG locking in Claude and Anthropic, that leaves a rapidly shrinking pool of massive legacy consulting firms up for grabs.
Very true.
I'm watching to see how OpenAI and Google counter-program to capture the remaining enterprise giants. It is a genuine land grab right now for corporate dominance.
It really is.
But before we sign off, I want to leave you with a mind bender to mull over on your commute or your walk today. We've talked about AI agents being deeply integrated into your personal finances via Plaid and into corporate tax audits via KPMG.
Yeah.
If these agents have that level of financial access, context, and reasoning, how long until we see 2 autonomous AI agents negotiating a corporate merger or even negotiating a salary raise on your behalf completely without human intervention?
Wow. I mean, if the compute stays cheap and the agents stay persistent, we aren't talking about science fiction anymore. We've built the highway, we've paved the on-ramps, and now the cars are driving themselves.
That's your Tech Hoon for this week. I'm Jess.
And I'm Mark. This podcast is produced by SBN Media Studio. Subscribe, leave a review, and we'll see you next Sunday.